Thank you, David, and hi, everyone. As David said, my name is Anoushka Concepcion, and I'm an Extension Educator with the Connecticut Sea Grant Program and UConn's Cooperative Extension System. And I will be talking about seaweed farming and what we can do with the seaweed that we farm. So just to go over what seaweeds are for folks that are not familiar, they are not plants. They do photosynthesize like plants do, and they do have structures that resemble components of plants like leaves and stems, but physiologically, they're different organisms. Seaweed are macroalgae. I'm sure some of you have heard of microalgae, but then obviously this is the macro version of the microalgae. There are three types of seaweeds: the reds, like Irish moss, browns, like sugar kelp, and greens like sea lettuce or ulva. And then the colors, the designation of colors have to do with the types of photosynthetic components that are in these seaweed tissues. So seaweeds are important for a variety of reasons. They contribute to a healthy coastal ecosystem. They extract nutrients and contaminants out of the water. They also provide habitat for marine organisms, as well as food for those organisms and food for humans. Seaweeds are also versatile. They could be used in a wide variety of applications. Not all seaweeds are created equally, and so it's important to note that we can't use seaweeds, all species of seaweeds, in the same way. Seaweeds are special in their own way, and they have certain components that are appropriate for certain applications. So this graph shows the global production of wild harvest seaweed, which is the orange lines at the bottom, and compares that to the production of farmed seaweed. And around the 1980s, you can see from the graph, there was this major shift from the global production of harvested seaweed through farmed production as opposed to wild harvest. And that's a trend pretty much that we're seeing with a lot of aquaculture species. But really, I mean, it's with the seaweeds. When we think of seaweeds and how seaweeds are produced now, majority of it is coming from farm sources. And the two countries from FAO's latest data that are leaders in producing the most volume are China and Japan. And just to let you know about the market demand in North America alone for seaweed and mostly seaweed components as well, was valued at just over $11 billion. So seaweed may seem like an innocuous type of organism, but there's a really huge demand and interest. So I was asked to talk a little bit about how seaweed is produced. And so while hundreds of species are being cultivated all around the world, we also cultivate a few varieties and species in the United States. The most commonly produced species is sugar kelp, or Saccharina latissima. And sugar kelp is a brown macroalgae. It's a winter crop. So juvenile kelp, the nursery stage, occurs in the fall. The lines are deployed in the fall and then grows throughout the winter. And then it's harvested in the late spring, anywhere between 2 to 3 months, depending upon the region. Seaweeds, especially sugar kelp, is very nutritious. It's a delicious edible species. It contains dietary fiber, essential amino acids, iodine, magnesium, and other trace elements, but also vitamins A, B, C, and E. So it's extremely nutritious, very healthy, and very delicious as well. If you haven't tried it, trust me, it's good. So just a quick overview on how sugar kelp is produced, how we farm it. So we are still reliant, majority of nurseries are still reliant on wild stocks. And so around the fall, we go out, we look for kelp blades that have this black band on it. That's the source tissue. And the source tissue contains thousands of spores. We bring the source tissue into the lab, into the nursery, give it essentially different light and temperature treatments. The spores get released. It's collected, and then it's inoculated, or all those spores are inoculated into the tank. And the middle photo here shows you everything that basic nursery system. And so in this tank, there's filtered seawater, nutrients, and light. And what looks like tubes are PVC pipe with string wrapped around it. And the string serves as a substrate for the spores. And the spores settle into the string, and then they grow out. Then picture next to the tank essentially looks like PVC with fuzz on it. The fuzz are actually the juvenile kelp blades. And when they get to approximately 2 millimeters in length, it's then ready to be deployed out into the environment. And how that's done is the seeded string gets wrapped around the grow line. And then, of course, the last picture you can see, this is in the middle of the growing season for sugar kelp. The kelp then starts to grow right off of that line and then ready for harvest around anywhere between April and June. This is the basic schematic of a farm design. But the farm design is going to differ and vary depending upon region, of course, depending upon site. All farming is pretty much site specific, as well as scale of operation. So essentially, the farm design is the grow line, the long line or grow line that's attached to 2 buoys anchored to the bottom. And as the kelp grows, it becomes very heavy. It's mostly water. And so in order to maintain it in the water column, flotation buoys are added. It's important to find that sweet spot for kelp. Again, it's going to differ with location and growing conditions because kelp is photosynthetic. So we want it to have access to sunlight, but we also don't want it exposed to the air because in the wintertime, we don't want the tissues to freeze. So again, it's just trying to find that sweet spot. In some places, it may be more shallow. In other places, kelp is produced in deeper water. So these are some quick videos on how kelp is harvested. The first video I'll show you was provided to me by my Sea Grant colleague, Jacqueline Robidoux, with Marine Sea Grant. And this video essentially shows how kelp is harvested. It's pretty much done similarly across the country. We use this process as well in Connecticut. So essentially, the kelp is just literally cut from the lines into some sort of container. In this case, this farmer was using bags or totes, and then the totes are then taken to the dock and then processed. And in Alaska, my colleague, Missy Good from Alaska Sea Grant sent me this photo. Kelp farms are much bigger in Alaska, and therefore mechanized harvesting techniques have to be utilized. What's really cool about the fact that the biomass is so large, what the farmers do is they have these floating totes that they pack full of kelp, and then it gets tendered back to the dock for processing. A little about processing, because kelp contains very high water, or very high level of water in its tissues. It has a very short shelf life. And so it's really important to process the seaweed or stabilize the seaweed in some form as soon as possible to maintain product quality. And so these are just some techniques that some farmers, but mostly first step processors, employ when they receive raw seaweed. There's blanching, which is the first photo. So blanching is not cooking, as we want to preserve the enzymes. It's a way to just sort of fix the kelp so that product quality is maintained. There's drying or dehydration. One farmer in Connecticut was trying out flash freezing. He said the quality was great, but the cost to do it was exorbitant, and he decided not to do that. But he just took this really cool photo. It provides an option as well for folks that are interested. And then this picture the last photo came from, again, Missy from Marine Sea Grant. What this company does is they blanch kelp, and then they vacuum pack it and store it. And then all the kelp then gets sold to value-added processors. So I'm going to switch gears now and talk about, sort of throw some numbers at you about the status of the industry in the United States. When we talk about seaweed farming in the United States, we have to talk about Maine. Maine has been producing seaweed and also seaweed products for 60 years. While the industry in Maine is mostly, or is predominantly wild harvest, they wild harvest rockweed, which is used for a lot of non-food commodities, fertilizers and animal feeds and things like that. There is an aquaculture industry that's beginning to increase in order to supplement the seaweed that's being utilized for food. In Maine, they cultivate 3 species of seaweed, so sugar kelp, skinny kelp, as well as wing kelp. There are a lot of farms in Maine. There's more than 200 sites growing a combination of shellfish as well as seaweed. And then there's also some standalone seaweed farms as well. The numbers for farmed kelp, a combination of farm kelp, 2020 for the 2020 landings was approximately 500,000 pounds. So a significant amount of seaweed that's being produced solely through farming. These are just some examples of the value-added food products that the farm product gets diverted to. Things like kimchi, kelp kimchis, and seaweed salads, and smoothies, and powders and flakes. And these companies, again, have dedicated many, many years to developing these products and then scaling up their manufacturing. And so they're at a point where you can go online and you can order directly from their websites. All right, so moving down the East Coast, we have Maine, and then we have everyone else. And so I put all of the everyone else, Connecticut included, into this table because the scales of operations are very similar, but then different from Maine, smaller than Maine. So really what I want you to take home from this table are the similarities. So from New Hampshire down to New York, we're all growing sugar kelp. We're all selling sugar kelp in its fresh, raw form because we don't really have processing facilities available or access to as many processing facilities like they have in Maine. And we're all mostly selling our sugar kelp to as a food directly to restaurants. One thing I want you to also notice is the row of number of farms. There are a good amount of farms, for considering the size of our operations, which are very small, that have been permitted. However, just picking on Connecticut, I can, since I work in Connecticut, we've had 13 commercial farms that have been permitted since 2001. However, only 3 are active. There's several reasons why. I'm going to talk more about that when I get to barriers. But just keep that in mind, that while there's interest and while there's a lot of permitting that or farms that have been established, not everyone's farming. And also not every farm is farming at capacity. So again, I'll talk more about some of the reasons why in a minute. I want to switch now all the way to the other side of the country and going to Alaska. Alaska by far produces, in volume, biomass, the largest amount of farmed seaweed in open water systems. They produce a combination of sugar kelp, ribbon kelp, and bull kelp. Out of the 22 sites permitted, 7 have been active, consistently active. Just for numbers, just under 540,000 pounds of a combination of these species of kelps were harvested last year. Unlike southern New England, and similarly to Maine, Alaska is not selling their seaweed in its raw, fresh form. They are stabilizing it as soon as possible. Ways of stabilizing include drying, blanching, and freezing. And then all that seaweed is diverted to value-added or to producing value-added products. So really, food production is the dominant commodity and ideal market outlet for seaweeds. The rest of the West Coast, again, we'll lump those folks together. Sorry about that. But really, in addition to the different types of species that they produce, it's important to note that most of the commercial farms are land-based. And the only open water farms, there's one in Washington that produces sugar kelp, and then one in California that's more of a nonprofit research farm. They're also producing sugar kelp as well as bull kelp. The seaweed that's being produced, or I should say farmed, is also going to food and human consumption, as well as some being sold as fresh. So, switching gears now to talking about barriers. I don't want to sound like a Debbie Downer, but I want you to keep in mind that these are very realistic challenges that folks in Extension, like myself, get asked a lot about. And it's the barriers that sort of keep all of us busy and trying to help folks navigate them and also address them. But I also want you to keep in mind that barriers also present an opportunity. So I challenge all of you to start thinking about how you would realistically address some of these barriers in an achievable way. Some of these barriers, while they're similar across the country, they're very nuanced by region, but also by scale of production and size of operation. Have to start off with markets. Market dictates everything. If a farmer can't sell their crop, they're not going to grow it. Just, basic business planning is key in this case. Some of the challenges faced by farmers who are selling their seaweed in its raw, fresh form, in terms of establishing long-term markets, is the fact that when they're selling in a raw form, they have to sell their seaweed in very small batches, but also move the seaweed as quickly as possible. Some of these farmers, some farmers, especially in Connecticut, have said to me, it's challenging when I'm bringing my seaweed to some potential markets because it's not necessarily the same seaweed that is being imported into the US. And what we import is not native, so we don't grow it. Sure, kelp may not necessarily be used in the same way, but that doesn't mean it's not similar. And so it's trying to provide, or folks have been really inventive and innovative in terms of how they market their fresh crop, so that it gets folks excited about trying it and demanding specifically locally produced fresh seaweed. Infrastructure for long-term storage for post-harvest processing and stabilization is also a challenge. Again, it's part of the reason why many seaweed farmers are selling their seaweed in its raw form. There's just no place to process and store long-term to ensure food safety, but also product quality. Some of the challenges small-scale farmers face are the cost of real estate, cost of utilities, and also being located close to a place where they can have access to a processing facility. And part of the challenge, I think, also some farmers face is just understanding what the market wants. Do they want fresh product? Do they want dried? Do they want blanched, frozen? And so understanding, again, going back to market will sort of dictate what some of this infrastructure may look like. Have to talk about regulations, right? So there's always issues and challenges navigating any regulatory process. But and again, that's going to differ with state. There's some states that have a well-defined regulatory process for both permitting and food safety, and there's other states that are just starting out. And so again, navigating through this process and figuring out what works best for a farmer and even what information regulatory agencies need can also be challenging. For example, with permitting, what does the permitting structure look like? How much does it cost to go through the permitting process? How long is it going to take? Also, from food safety perspective, if a farmer is selling their seaweed raw, are there food safety concerns that they need to be aware of? It's one thing if a farmer has the ability to process their seaweed, to stabilize their seaweed in a safe way. But raw food, there are potential food safety hazards. But farmers ask me, do I need to take a food safety training course? If so, how much does that cost and how long is that going to take? So when developing business plans and planning out the kelp farming process, a lot of it actually has to do with the post-harvest challenges, right? The markets post-harvest as opposed to just growing. And so it's sort of like a shift in mindset to say, I can farm seaweed, but then what? And so let me shift my energy and focus on the now what in order to be a successful farmer. And I also added production for two reasons, especially in Southern New England and Connecticut specifically. We've had challenges with weather and how weather impacted farming. For example, there's been some years where we've had icing of lines as well as nor'easters that have torn apart kelp lines, resulting in crop losses. And so preparing for that situation without violating your permit also has to be taken into account. And also, some of our farmers have faced challenges accessing seed. And you can't farm anything if you don't have the seed. And there are many reasons for this. It could be location to the closest nursery. It could be not securing contracts well ahead of time with a nursery. And other factors such as regulatory factors, importing seed from outside of the state could also add additional barriers to accessing seed. There's some concerns in some states where or concerns with introducing a non-native strain into local waterways prevents a farmer from, for example, Connecticut farmer going up to Maine and saying, let me just get seed from Maine. There are those regulatory barriers that prevent access to seed. But really, to sort of address some of these challenges, there are resources available. So the National Sea Grant Seaweed Hub was established in 2019. It's one of 11 aquaculture hubs that were funded by the National Sea Grant Program. And this is a collaborative effort of 11 Sea Grant programs and their stakeholders. And essentially what we did is, we hear all these questions, we hear folks talking about these challenges. And so we decided, let's bring everyone together and let's let the stakeholders come up with solutions and then develop resources based on the needs, challenges, and potential solutions on how to address these barriers. And so these are some resources that are available, publicly accessible on seaweedhub.org. One is the State of the States. And this presentation is updated annually by all the Sea Grant programs. And essentially, I pulled from this presentation in order to put together my slides about each state. And again, it just provides an overview of landings, the regulatory process, species produced, and where the seaweed is going. We've also developed this quick, handy infographic called the Commercially Cultivated Domestic Seaweed Aquaculture or Seaweed 101. And it's really a guide to where seaweed is grown, so which states are producing it, which species, and where it's going, where it's being sold. And then to address seed access, some of the stakeholders said, you know what, let's take a step back and let's figure out where the sources are. And so what came out of that conversation was the National Seaweed Nursery Directory. It's the first of its kind that did an assessment of seaweed nurseries, or I should say seaweed sources across the country. And then it was an opt-in nursery, it's an opt-in directory. It's going to be updated every year, but at least it provides farmers with a place to start, but also what restrictions and guidance there are depending upon what state a farmer is located in, which could dictate and determine where they can source their seed from. And I did want to give a shout out to all my Sea Grant colleagues. The Seaweed Hub is a collaborative effort. And so these are the folks that make the Seaweed Hub so successful. So these are the folks I go to when I have a question about, what's happening in Alaska or what's happening in Massachusetts. So if you do have questions about a specific state, I urge you, reach out to these folks. They're extremely knowledgeable. They know what's happening all the time. Their contact information is also on the Seaweed Hub's website. And so I wanted to now shift gears and talk about really cool potential applications, different ways seaweeds and components of seaweeds can be utilized. Keep in mind that a lot of these applications are still in the research phase or in the pilot phase. They haven't been scaled up. They're not commercially or accessible yet to a majority of farmers. But here's what's happening, right? And here's what's coming on the horizon. So just some of the applications for seaweeds include biofuels. There's a lot of federal funding that's been going towards investigating, developing biofuels out of seaweeds. Now, while the target organism are microalgae, for a number of reasons, microalgae can produce really large densities or high densities in a very short period of time. There's interest also in utilizing the biomass from macroalgae. The challenge, though, of course, comes back to processing and having biorefineries and facilities readily available to accept all the material and biomass and transition it into a biofuel that can be used really worldwide. And also thinking about a decent amount of decent price point for farmers. Remember, farmers are selling right now their seaweed for food because they can get a premium price for it. It's the highest value commodity, which is great, which is important. But there's also a lot of farmers that have kelp left over, for example, or kelp that sort of, towards the end of the growing season, the product quality may not be as great, still safe, but just may not be as great. And so these are the potential market outlets for some of those farmers. So again, biofuels, hopefully soon will be one option. This is something that's really cool, biotextiles. So you may have heard of bioplastics. This is sort of, similar in terms of developing a material that can replace plastics and other forms of textiles that's biodegradable. This company, Oceanium, is one of many companies. They're based in Europe, but they're looking at utilizing macroalgae material to producing a biodegradable textile. This is a leather-like kelp material. It's one of their prototypes that they've developed. They're also looking at producing prototypes for a seaweed-based ink, as well as seaweed-based films and boards. But, while that sounds great, again, the challenge comes down to now. What's the situation now? Again, it goes back to infrastructure and having the appropriate infrastructure to be able to transition all that material into something that could be turned into biotextiles. And in addition to infrastructure, scaling up the technology as well still needs to be figured out. This is something I get asked a lot about, and same thing with my Sea Grant colleagues, is utilizing or incorporating seaweed into livestock feed to reduce methane emissions by cattle that are produced to supply the dairy and meat industries. So the ideal candidate species, I should say the one that's being targeted mostly, is a non-native species, unfortunately. It's a red tropical, subtropical macroalgae called Asparagopsis taxiformis. And by the way, this is a great resource developed by the World Wildlife Fund that sort of gives you an overview of some of the key points and factors in utilizing seaweeds into livestock feed. But anyway, Asparagopsis taxiformis contains a compound called bromoform. And bromoform has been shown to counteract the formation of methane in the cow's gut. So when added to feed in small amounts, it's been shown to reduce methane production, or cow burps, let's be real, by almost 95%. So the data is wonderful. But again, it's part of the challenge with scaling up and having acceptance, widespread acceptance within the dairy industry. And the lead researchers, the lead researchers are based at UC Davis, as well as other universities and globally as well. Here's another application that a lot of municipalities are interested in, is utilizing seaweeds for ecosystem services, essentially cleaning up coastal waterways. Again, seaweeds are extractive, so they are really good at absorbing nutrients directly out of the water column. But with nutrients, they're also great at absorbing heavy metals and other chemicals and contaminants of concern. Part of the challenge with this process, though, is developing a long-term economically viable program that can be implemented, where the funding source is consistent long-term. So who's going to pay for it? How much are the farmers going to get? And also what to do with all that material, especially if there's high levels of contaminants. If the seaweed was cultivated in an area, perhaps, or for example, that was close to, say, shellfish farming. If that seaweed has high levels of contaminants, you can't put it back on your tomatoes. It's just going to go right back into the food chain, right back into the ecosystem. So again, having those practical challenges addressed and having a plan in place is something that still needs to be figured out. And here's something that I just never thought about. I met this amazing sustainable fashion designer. Her name is Runa Ray. And she told me this staggering number. It's crazy that just the fashion industry alone, the process of dyeing fabrics and printing fabrics to make clothing, it contributes to 20% of global water wastage and water use. I had no idea. And so she's implementing this ancient Japanese technique of using floating inks. And I probably should have made this photo bigger, but you can check out her website. The floating ink pattern makes this beautiful marble pattern on fabrics. And but the floating ink technique requires a really viscous solution. And what she utilizes to make the solution viscous is carrageenan from red seaweeds. And so that is another potential application that can reduce global water usage if implemented on a much broader scale. And so I think it's really important, while the immediate market outlet for seaweeds is food, because again, high value commodity, really healthy, nutritious, delicious food source. It's important to not discount the other more industrial applications for seaweed. If there's an interest, it justifies more investment into making some of these non-food applications a reality and a viable option for farmers. And I wanted to end the presentation with just letting you know that a lot of these conversations and that we're having in the US, challenges, barriers, opportunities, it's happening globally. So it's not just a US situation, it's a global situation. And one organization called the Safe Seaweed Coalition, they're focused on scaling up the global seaweed farming industry, building a safer seaweed industry through 3 pillars of safety. So it's operational safety, consumer safety, and environmental safety. And you can see their website, safeseaweedcoalition.org, for more information. But they're also a funding agency, not funding agency, but they provide funding for projects that address these 3 pillars, that align with these 3 pillars to, again, grow the industry in a really safe and responsible way. And that's really all I have. So thank you very much for listening to my presentation.